What I'm gonna do is show you the next steps that you will be doing on these two projects. So not only are you gonna be drawing them in 3D and showing me based on a 0-0 positioning and everything, which I've got up here on the board, we'll talk about when I hand them out. But what you're also gonna be doing on this one is taking these drawings or these 3D objects into an 8.5 by 11 or 11 by 7 into a border and title block. So I'm gonna show you how to bring it into a border and title block once you draw the 3D. I'm gonna show it to you on a couple of different border and title blocks that we've got. And then we'll talk about how yours is gonna be turned in. So on this particular object right here, I've drawn it based on the information that I was given. Not just the dimensional information, but also 0-0. So on this one, we had 0-0-0 on the bottom corner right down here of that block. We had it positioned in that direction, which was our Y direction up, which is also, if you look up here on the view cube, AutoCAD also understands that to be your north direction. So we've got this object that we've drawn in 3D. The next thing we need to do is take it into a drawing for a presentation or a fabrication type drawing. So on this object, what I've got over here is when I come up here and click on my view cube on the top, remember you always want to make sure that your WCS is set right here. So when I look at this and it says top, that is what is going to show up as my top view. If I click right down here and spin my view cube, up here on my view cube, this says front. That is what the front view of this object will look like in 2D. When I spin it, spin it around here to where my view cube says right. This is what AutoCAD is identifying as the right side view. So understand that when you make these 3D objects and you turn them into a 2D fabrication type drawing, whatever that view cube shows up there is what it's going to be considering its top view, front view, and right side view. So what we're going to do, we've drawn this object in 3D. The next step you will do to bringing this into 2D. So I'm going to show you a little step by step. It would kind of be in addition to that drawing sequence document that I gave out at the start of the semester. This would kind of work in relation with that. We're at the drawing the parts segment. Next step on that drawing sequence says to select the correct border and title block. So I'm gonna do it on the 8.5 by 11 first. So I come down here, pick the 8.5 by 11 border and title block. Once again, just like before, we're not worried when we come over here if we don't see anything. We understand what's going on. Our object just isn't drawn inside that view area. It's not a problem though. So what we've got here is a 3D object we're bringing into a 2D drawing. This is where that drawing sequence would kind of vary a little bit. We're not going to double click inside this window, inside our viewport, find our object, we're not going to do that part. When you're doing a 3D object, the next step that I'm going to do is I'm going to erase that viewport. If you've got some section views that we'll talk about probably in a couple of weeks, if you're doing section views of the object, that would be a little bit different. We would still want our viewport for that. But for what we're doing right now, just bringing that 3D object in for a front, top, right side, ISO type, orthographic and isometric views, we erase that viewport. You can change to a particular layer if you want to, but I usually just keep it in one of my same 3D layers. We've got this command over here called the base command. So I'm on my 3D ribbon in AutoCAD. I'm on the home tab. So all the way down here at the end, we've got the base command. When I click on that and expand that command, you'll see that we've got two options there. We can either bring that 3D object in from AutoCAD's model space, or we can bring that 3D object in from Autodesk Inventor. So in this case, we're going to be bringing it in from model space. So I'm going to click right here on model space, and you will see that the view that I'm showing you, if you noticed or remembered this object, what I'm looking at, our primary view, what AutoCAD calls our parent view, is coming in as the front view. So that's why it's very particular to have your object oriented and located correctly over in model space. Otherwise, your front view is not going to be what's the front view of the object. It might be the right side. You got your object turned 90 degrees over there in model space. So whenever you bring this view in, the parent view is defined as the front view. So I pick right here, AutoCAD is asking me where do I want to put this main base parent view. If I'm only doing two views side by side, I might stick this view right here and then show my right side view over here. If I'm doing a top view and front view, I might do this one in the middle right here, and that way I can have my top view up here. Because I'm doing the 3 orthographic view scenario, top, front, and right side, with an isometric up here, I'm gonna come put my front view down here. I can always move it later if I need to. I'm gonna click right here and say, put the front view right here. AutoCAD asks me a question down there, gives you some options as we go through the command. You're more than welcome to look at it, but the presentation that we're gonna be making right now will be just running straight through the command, selecting where you want those views to be just like it is, no modifications. We'll be changing some after the fact, but not while we're going through the command. So when it says select an object, I'm just gonna hit enter or space bar, go with the default. AutoCAD then says specify location of projected view. So I would like to have a front, top, and right side view and an isometric. We've already got the front view, so I'm gonna move my cursor up here to where the top view would be. And you can see the little object that's showing is changing. You can see that if I move my cursor a little bit to the left or right, AutoCAD understands that orthographic views have to be positioned straight above or side by side with their other views. So I'm gonna come straight up here and say, well, I'm getting kind of tight, so I'm gonna have to move that front view down, but I'll do that in a minute. So I say, well, let me go ahead and finish positioning my views or putting my views on there. So I say, there's my top view. I also need a right side view. So as I pull my cursor in different directions, AutoCAD is showing me that view from that direction. So we want a front, top, and right side view, which would be these positions. And then we also want an isometric view. So when I move my cursor up, this view does not change anywhere in between those other views. If I'm moving around here, it's not like it's turning a little bit more over till it gets to that point. No, it's the same isometric view. It's just asking you where you want to place it at. If I move my cursor up in this direction, it's an isometric view over there. Down in this direction, it's that bottom isometric view. And then over in this direction, it's the bottom isometric view over there. So it's all breaking off of that one parent view, that main front view that we put in first. So I'm gonna say this is where I want my isometric view to be. AutoCAD is gonna continue saying, do you want to change that view or add another view? Do you want to put one over here, over here? Do you want to show the left side, the back view? We're just going to show those primary views. So when we get through with that, we hit enter to complete our command. So once again, the positioning isn't that great. I didn't really know how big it was going to be, where it needed to be positioned at. So what I'm going to do now, I'm going to say, well, I need to move this view down. And then I'm going to have to move this view down the same amount. And maybe I want to move this view over a little bit and get it off that side. So when I single click on that parent view, you can see that I've got two options here of selections. I've got that blue box grip right here, standard square blue grip. I can click on that grip, which allows me to pick it up like a handle. Watch what happens if I move this view to the right. You will notice my top view is moving also, because AutoCAD knows that orthographically those have to be lined up vertically. And if I say, well, I want to go to the right a little bit and I want to go down, when I start moving it down, you will see that other view over there starting to move also. So AutoCAD keeps those views linked to each other. If I come over here and select this view and I grab this handle and go to move it up, it won't let me because that parent view is forcing it to stay vertically right there. It'll let me go left or right, but it won't let me move it up. If I wanted to move it up or down, I would have to come back over to the parent view to be able to do that. So that quick and that easy, I was able to bring my three views of my object in, position them orthographically in the three orthographic views, and do an isometric up here. Any questions about what I did so far? All right, on your isometric view, we know that we're not supposed to show hidden lines on an isometric view. AutoCAD by default, unless you go through and change some of those settings on the way through, AutoCAD is going to show that, so what you can do is you can single click on it. AutoCAD adds this drawing view tab to your ribbon, gives you a new set of commands over here. I can pick edit view. It's only editing this one view that I have selected. I can pull this down and tell AutoCAD to just show visible lines, which is what we need for our isometrics. Hit escape to clear my grips. AutoCAD changed that view to not show hidden lines. On this view right here, or maybe I say, well, I want this view to be bigger, which we really wouldn't do. We can pull down and change the scale on these individual views, these orthographic views, but normally one view will match the scale of all views orthographically. So if I want to change these views, I'm gonna need the scale, I'm gonna need to change the scale on all three of them. So I can individually change scales, but that's just a bad habit to get into, because now you have to change this one and you have to remember to come over and change this one and this one. If you just come to your parent view from the start and change that scale, it'll change all three of those, all of those views. So what I was doing, I was coming over, you see when I click on the parent view, it shows me that scale is 6 inches equals a foot. When I come back over here to one of these alternate views, it does not show me what scale it's currently at. So for me, that would kind of be a problem. Before I'm gonna change it, I'd like to know what it's at. If I want to make it a little bit smaller, well, which one is it at? So I'll know which one is next. You're gonna find that information on your parent view. That's the one that'll light up the current scale. Maybe you say, well, I want this isometric to be a little bit smaller. It doesn't fit up in the corner. Remember, the isometric does not have to be drawn to scale, so we can actually make it smaller or larger if it helps. We can individually change that size. Well, now it's too small. Let me try going bigger with it. Well, now it's too big, so yeah, I guess 6 inches equals a foot is the best scale. So we can go through and play around and modify and manipulate our drawing, once we put it on there, change our scale if needed, and then we say, okay, now I've got to do some dimensions on that. Now we're back to the norm of before. We're going to come over here, go into our dimension layer, which I don't have on this drawing. We're going to come over here to our annotate tab. We're going to show our dimensions just like we normally would. The same dimensions that you would normally be showing based on the handout or whatever you're working off of. You can see that AutoCAD is recognizing all of those object snap points. So I can go through and I can dimension this object and I can make some good, clean dimensions. Now here's something you'll see when you're dimensioning in 3D. See those little yellow boxes with that exclamation point in there? The reason that is on there is because when we're dimensioning this 3D object, and even though I move my cursor down there and I pick a point that recognizes and is that end point right there, if it is not an object snap point of that object itself, AutoCAD will give you an error. What I mean by that is that when I went into that dimension command, AutoCAD says specify first point. I said, all right, this midpoint right here. That was a good point. When AutoCAD said specify next point, I came down here and it said node. That node is not an object snap point of the object, it's an object snap point of that dimension. That is why it is going to give me that yellow error, that yellow caution sign. If I would have went through there and said, you know, I don't want to go by that node right there, if I'd have said, let me go to the midpoint here, and let me go to the end point here, now AutoCAD recognized two object snap points of that 3D object. AutoCAD will give me a good clean dimension. It's not that that other dimension was wrong. They're measuring the same points. We know that. We know that that node is right there at that end point. But AutoCAD has that ranking for object snap points. And AutoCAD said, you know, node is more important than end point. So when you move your cursor over there, I know they're the same point, but I'm gonna show you node because I think that's a higher ranking object snap point. So that's just AutoCAD's ranking of object snap points. If you don't want to see those, like I said, you have to force some of those object snap points. Or what I could have done was I could have went linear and just got close to that point. Remember, once that object snap point lights up, AutoCAD has found that point. So if I don't actually go to that point, but I get close enough to where AutoCAD says, oh, there's an object snap point, is that what you're looking for? And once it pops up that little symbol right there for midpoint, I know I can click and AutoCAD is magnetized to that midpoint. And then same thing, I can move my cursor down here and stay away from that dimension, get close enough to where it reads that endpoint of one of these objects. Once again, it's reading object snap points of the 3D object, not of the dimension. It will give you a clean dimension right there. That little caution sign does not mean that it's wrong. It just means that it did not read an object snap point of the object. It read one of the dimension. So any questions on what I did there?
So that doesn't necessarily matter when you grade?
No, when you're sending it to me, you're gonna be printing the 2D out. That will not print out with it.
Okay.
So all that would show out on that print, which we know if I do a print preview, it's gonna look like crap, so I'm not gonna even try to show y'all that. But no, those 3 3/4, all 3 of those dimensions would look exactly the same when it comes out of the printer. So there is no harm by having that symbol on there. The downside to it is that if I go through and modify that part, the dimension right there is not gonna be locked to that endpoint of that object. So I may have to come back and fix that dimension later on. Whereas these other dimensions are locked to that endpoint. So if I move that endpoint, those dimensions will automatically adjust with it. 6 of one, half a dozen of the other, but if you have to go back and modify something, you'll be happy that those dimensions are locked to the object, not to the point in space, the node. So after you do your dimensions, you do your labels. Now, even if I showed you, I don't remember if I did, yeah, I did on this little view up here. So we're gonna talk about your 2 objects in a moment, but I showed you a north arrow up there. When you go and label your views, remember, do not show a north arrow, do not call it a plan view and elevation views. Just call it your standard top view, front view, right side view, and ISO. Don't show the north arrow on your finished product when you turn it in though. Okay, that's just for you to reference it. That gave us a reference, kind of like this. I could have given you a note on that drawing, that handout that I gave you for this block. I could have given you a note that said this corner, right, which I probably did. That said this corner right here is 0, 0, 0. This direction up there is your north direction. So now when you come over here in model space and you start drawing that 3D object, you can adhere to your top view, your north arrow over in this position. But just remember, it's going to be top, front, and right side for your view labels. So any questions on that process? All right, I'm going to walk around and hand some drawings out, and then we'll move on to the next step of the classroom. These are your 2 3D projects, or this is one of your 2 3D projects. This will be your homework that will be due 2 weeks from tonight. You will be doing these in 3D and in 2D. Up on the board up there, I've got your 0, 0 shown again on a little sketch for these 2 projects. And I've also got your 0, 0 called out on this drawing, but I do not have your north direction called out on this drawing. So make sure you pay attention to that before you leave, or give a picture of that before you leave. That drawing will be on 8.5 by 11 border and title block. This drawing will be 11 by 17 border and title block. This will be sheet 2. So make yourself a note of that. So the 8.5 by 11, the first one that I gave you, which is called tailstock, that one is going to be 8.5 by 11. So your finished product sheet size will match your handout sheet size. So on the first project, the tailstock, 8.5 by 11 border and title block, Once again, 0, 0 is in the middle of this shape. North is in that direction, so you will have to have some scale adjustment on that other page. So once again, this one's on 8.5 by 11. So what you're gonna do is you're gonna draw this part. You can put fillets on those corners. So if I go back to that block drawing that you did, just to show y'all, I don't remember showing y'all how the fillet command works. So when you go into the fillet command, F and space bar, what I'm gonna do is I'm gonna put a 1/8 of an inch fillet down this front corner right here, this edge on top of this little piece right here. I'm gonna put an 1/8 of an inch fillet on there. So when I go into my fillet command, you can see that AutoCAD says select objects, select first object. What I'm gonna do is move my cursor over that edge right there and select it. And you can see that it lit that edge up in blue. AutoCAD will then ask you to enter the fillet radius. Normally when you go into the AutoCAD, if you want to adjust the radius, if you're doing a fillet on a 2D object, you go into your fillet command. The first thing you do is R and space bar and tell AutoCAD this is my radius if you need to change it. When you're in 3D, it is gonna ask you that fillet radius one way or another. So had I gone into that fillet command and said F and space bar, and I said R and space bar, and AutoCAD says, okay, what's your radius? 0.125 and enter. AutoCAD says select your first object. I come up here and graphics is why it's still lit up. I haven't selected it yet. I come up and I pick that corner. AutoCAD says specify fillet radius. So at some point or another, if you're changing the radius, just understand in 3D, AutoCAD is gonna ask you whether it's the fillet or the chamfer. AutoCAD is gonna say, what's the radius? AutoCAD's gonna say, what's the distances? There's no sense in going through and setting it like you normally do in 2D right when you first go into the command. So I tell AutoCAD, yes, I still agree with that radius I told you. AutoCAD says select an edge, so I'm gonna select that edge again just to make sure. AutoCAD will tell you it's already been selected. So I hit enter or space bar. AutoCAD puts a fillet on that edge. On a 3D object, I can go back into it. Once again, I can pick that edge. AutoCAD says, what's the radius? I hit enter or space bar. I haven't used the whole chain feature a lot, but you can. You can select a surface, I believe, and AutoCAD will make it a chain all the way around it. So I picked the horizontal and vertical on these edges, and I also picked this horizontal right here, so I hit space bar. And you can see that AutoCAD put fillets on those corners. Why it's lighting up these other areas in blue, I'm not really sure. That's just some more of the graphics issue I think that we've been having with AutoCAD. You can see that you can put the fillet on any edge. So where that hole came out right there, I put a fillet on it. I can go in and put it on any corner or any edge in AutoCAD. So you do have some fillets on these projects. So your first one is the tailstock that is centered right there at the middle of that side, the midpoint of that side. So once again, when it comes time to turning it in, that drawing needs to be right there at 0, 0. You need to have WCS locked in up here at the top right. So to finish this project, you'll come down here, pick your border and title block, 8.5 by 11. Looks like I already been playing in this one, so I'm gonna delete that one. Go ahead and make me another one.
So are we gonna send you the 3D version and the 2D version?
Yep.
Okay.
I'm gonna select that 8.5 by 11, set current. I don't have a border and title block on this one, so I'm just gonna come over here and steal it real quick. Control-C, 0, 0. This dude. Control-V, 0, 0. Bam, there's my border and title block. So once again, on this one, we do not need a viewport. I'm going to switch to one of my object layers, or my only object layer. Base command from model space, front view, hit enter, space bar, top view, right side view, isometric, space bar to complete it. So this one right here doesn't look like it's fitting, so I'm not gonna fight it, try to make it tight, scrunched up. Whoops, wrong way. I'm gonna go to 3 inch. I thought it was at 6 inches equals a foot when I came in.
I think maybe going,
And no, it must have been down at 1/2 inch equals a foot. So that looks about right there. So now I'd be able to position my views. Don't forget on your isometric, if you have to make it smaller because those other views, you always can possibly go back up with your isometric of 3/8. So you might be able to scale your isometrics up a little bit sometimes. That's allowed, that's okay. These other 3 views need to stay at the same view. So any questions on what you're doing with your 3D projects for the next 2 weeks? Those are your 2 projects. Like I said, this one's sheet 1. Your other one, your 11 by 17 will be sheet 2. This one is called tailstock. And I've got it shown up here, representing your 0, 0 at the middle of that side. North, always on an isometric, so that'll orient it over there. But remember, do not show that north arrow. Do not call it plan view and elevations. It's top, front, and right side views in ISO. This is your second drawing, the 11 by 17, the cross feed stop. There's your 0, 0. You can see it also shown on your drawing. And it's also north in that direction. That is sheet 2. Any questions on that? What you got?
Will we turn in the 2D ones? Are we gonna be printing them out? Or?
Yes. Yeah, you'll print those out and then you'll send me the electronic copy for the 3D check. Remember, it's last name and the project title. So you're gonna have 2 different names on these. It's not like sheet 1 and sheet 2. Your names are cross feed stop and tail stop. Got everybody good on that? All right. Let me read my spiel. It says, good morning, afternoon, evening. My name is Nate. All right. Good afternoon. My name is Mr. P. I'm here to administer the Community College Survey of Student Engagement, or CCSSE, a national survey run by CCCSE at the University of Texas at Austin. Your participation in the survey is entirely voluntary. There are no penalties for choosing not to participate or for stopping at any time. That's a big one. The other night, I had 2 classes that got drawn. So the other night, and anybody that was in the class that did it the other night, you can't do it again. Sorry.